All right, so when we left each other last time, we had started talking about on the front side of this symbolic arguments, and we had gotten as far as forming the argument. So just to refresh your memory, and then what I'm going to do is I'm going to flip to the other side because I had asked you as part of your homework if you would get as far as forming the argument of example 3. So I don't know if you did that or not, so we'll do it together. So our process goes like this. We are being asked to show if this argument here is a valid argument or an invalid argument. So the first step that we have to do is we have to write the argument symbolically. There's nothing new for us in step 1. This is stuff we've been doing since the first section of this. It's just defining your simple statements, which we did here, and then writing the 3 statements, the 2 premises and the conclusion symbolically right here. So this whole first step, that's just kind of a review step of where we've been. Then the second step, this is really the new stuff because the third step again is going to be something that's review. The second step is the only bit of new information in showing if an argument is valid or not. We have to form the argument. And the way we do that is we take this in this case, 2 premises, if P then Q and P, and we connect them with a conjunction with an and statement. And notice that I've grouped them together with the brackets. And then we say, does that imply, okay, that's what the arrow is. Does that imply, does that always lead to the conclusion Q? Okay, so I'm stressing this because this is the new bit. This, for some students, is the hard bit to this. The last thing we're going to do is we're going to do a truth table for this, and I'll tell you what to look for to know if it is valid or not. So again, for example 2, we did the same thing. Here's the argument. We defined our 2 simple statements, and then here is the argument written symbolically right here. Again, this first step right here, this is not new information. That's section 1.1. The new information right here is forming the argument where we take the premises and we ask, does that imply the conclusion? So here are my 2 premises. If P, then squiggly Q, and notice the conjunction, and the second premise down here on the left, Q. And I've grouped those together with a bracket. And does that imply, does that lead to squiggly P, which is the conclusion? Okay, that's where we got to last time. So then I asked you as part of your homework to save us a little bit of time. Do you have a sheet? Are you okay? Good. To save a little time for us today, I asked if you would do example 3, if you would do those 2 steps. So let me do this just because I don't know if you did it or not or had time. I'm going to give you 2 or 2.5 minutes to do as much of that as you can. Okay, so I want you to take example 3. I want you to define your simple statements. Then write the argument symbolically. That's the review. And then if you have time in this 2 minutes, form your argument. No, we haven't. I haven't talked about that step yet. Yeah, you're not responsible for that until 5 minutes from now. All right, so simple statement P, I have defined to be the grass is green. So I'm just underlining. And then statement Q, the grass is full of weeds. Now, remember I mentioned this last time. If you defined your statements with different letters, or if you did them in reverse of mine, and your statement P is the grass is full of weeds, and Q, the grass is green, that is totally fine, okay? Your conclusion will be the same as my conclusion. You'll just have to make sure that you know that your P's and Q's are reversed of mine, that's all. Okay, so now the first statement is the grass is green or the grass is full of weeds. So that first premise is P or Q. The second premise is the grass is not green. So that is squiggly P. Therefore, and I told you the cool math symbol for therefore is 3 dots arranged in a triangle. The grass is full of weeds. So that is Q. And there's my argument. Sometimes I'm seeing this in the chart. I forgot to mention it. Sometimes some people treat this like an arithmetic statement and they'll draw a line there. I don't care. Do that or don't do that. It doesn't really matter to me. So that's step one. That's, again, that's not new. If you have questions about that, go back to your homework on section 1 and where we talked about writing things symbolically. Step 2 is let's form the argument. So the argument says, okay, I am going to group the premises together and I want to know, does that always imply my conclusion? Okay, does that have to be true? So the argument goes like this. In this case, my premises are P or Q. That's the first premise. And squiggly P is the second premise. I'm grouping those together. And I want to know, does that always lead to the conclusion of my last thing here, Q? All right, so now I'm going to turn the page back over. And for my first example, I'm going to show you the last step, okay? Because now that we formed the argument, that is the new bit of information. That's step 2. Now that we know how to form an argument, the way that we show if it's valid or invalid is we do a truth table. And so I'm going to do a truth table if I can squeeze it in here for this first example that we did. Okay. The way that we show if it's valid or not valid, well, let's do the truth table and then I'll tell you how we know. Okay, so let's see. So I'm mainly going to give you arguments with 2 simple statements just for time's sake when you're taking the test. I don't want you stressing. I think on the homework there might be 1 or 2 that have 3 simple statements. The whole process is identical. Okay, but when you have 2 simple statements, I just have a P, I have a Q. Here's my truth table. Remember, we have T. They could both be true, true, false, false, true, false, false. I'll have to adjust my writing there a little bit. Let me do this just because I want to be a good instructor and I want you to feel like you're getting your money's worth here today. Okay, much better. Got all the room we need now. Okay, so I need to do a truth table for this statement right here. So where you're going to start your truth table is we're going to start in the brackets. Okay, we want to get the truth value for the stuff in the brackets. So I'm just going to work on the stuff in there. So the first thing in the brackets I have is P, then Q. This is great review for us because we've got a test the next time we're together. That's the conditional statement. When is the only time the conditional statement is false? True then false. That is great. So true then true is true. True then false is false. False then true, true. False then false is true. Then what I'm going to do, looking back up here at my argument, I've got if P then Q, and then I'm going to connect that with an and to P. So my next column is going to be P then Q, and then I'm connecting it with an and with P. So here are my 2 columns. I've got the P column, I've got the P then Q. Again, great review opportunity. The conjunction, the and statement. When is the and statement true? When they're both true, sure. So here we go. The first line, true and true. Okay, that's a good one. The second line, true and false. Okay, that is false. The third line, false and true. That's going to be false. And finally, the last line, false and true. That's going to be false. Well, on this particular one, we only have one more thing to do because the conclusion is just a simple statement. There's no compound statement. There's no negation over here. So my last thing, I'm just going to draw an arrow if you don't mind, just to save a little ink on my pen. Okay, this last one is just going to be the end of the argument. So what we're doing is we're combining this column that I'm asterisking and this column. And I told you back when we talked about the conditional statement is the only one that order matters. So I like to remind myself what order I'm going in because I will lose track of myself. So I'm going from this column to this column over here. So here we go. The first one, true, then true. That is good. The next one, false, then false. True. The next one, false, then true. It's good. Last one, false, then false. It's good. And so now we have to answer the question. And the question was, is this a valid argument? This argument that was up here, if the figure has 3 sides, then it's a triangle. The figure has 3 sides, so that's my given information. So I want to know, therefore, it is a triangle. Is that always true? Is that the only conclusion that I can draw from that given information? And so the way that you know if an argument is valid is if you end up with a tautology. And if you were here the day we defined a tautology, tautology is just the fancy math word for the last column is all trues. If you get a tautology, then what you have is a valid argument. What that tells me, okay, the reason it's a valid argument is it tells me no matter what the premise is, I always get truth. Okay, it always leads to this conclusion that it is a triangle. If there's even one false in this column, it's an invalid argument. That means there's a loophole or a crack in the argument, whatever terminology you would use. Yes.
Why did you do biconditional?
I did not do the biconditional. The conditional just goes one way, but this is the premise right here. And then this right here is the conclusion. So my conditional statement is going that way. All right, so what I would like you to do, please, I'm going to leave that up there, but below that on your paper, or actually I'll show you, here is the argument we formed for example 2. So I would like you, please, to do the truth table and determine, is that argument valid or not? I'm just going to get started on the truth table. So if you're working, keep working. It's totally great. So first thing I'm going to do, again, I'm going to work inside the brackets because I need to join my premises together. So I have this statement here, if P, then squiggly Q. So first thing I'm going to do is I'm going to get a squiggly Q column so that I can figure out what that statement is. So squiggly Q just changes the truth value of the Q column. So it becomes false, true, false, true. And now I'm going to do the first part of my premises, which is P, then squiggly Q. You've already answered the question for me. The only time the conditional statement is false is when you have true, then false. So true, the first one, P, then squiggly Q. True, then false. That's the false one. The second row, true, then true. That's going to be true. The third one, false, then false. It's true. The fourth one, false, then true. It's true. Then I'm going to finish off my premises. I'm going to take what we just did, that column with the P, then squiggly Q, and I'm going to conjunct it, which I don't know if that's a word, but it is now. I'm going to conjunct it with the statement Q. So I've got P, then squiggly Q, and the conjunction, the and statement Q. Okay, these again, remember, these are my premises. I've linked my premises together with an and statement. And so the and statement, so here we go. Here's my Q column. Here's my P, then squiggly Q, true and false. Yes. Yes. Yes, that is a great question. When you link the question, in case you didn't hear on the video or in the rest of the class, is in my premises, will I always link them together with a conjunction? And the answer to that is yes, always, every time. Okay, it will never be different than that. And what that's saying is this is my first bit of given information and this is my second bit of information. They go together. It's a great question. Thank you for asking that. So now I've got my if P, then squiggly Q and Q. So here's the Q column on my left finger. Here's the P, then squiggly Q on my right finger. And so the true and false, that's going to be false. The next one is false and true. That's going to be false. The next one is true and true. And then the last one is false and true. So remember, the conjunction is true only when they are both true. Now I want to know those premises, do they always lead to this conclusion? Well, the last problem we did, the conclusion was just a simple statement. Here on this problem, what I need to do is I need to evaluate the squiggly P first, and then we'll be ready to rumble. So P way back here on the left, true, true, false, false. So squiggly P is false, false, true, true. And now I'm ready for the argument. The argument is my premises right here. This is my conclusion right there. And so I'm just going to draw a big arrow to indicate this is my last step. Once again, I am scattered, especially this morning. It's been quite the wild ride for me. So I'm just going to draw an arrow up here that I'm going from the premises to the conclusion. I'm going in this direction right here. So the conditional statement is only false when you have true then false. So let's see what happens. So false, then false, that's good. False, then false, that's good. True, then true, that's good. And then false, then true, that's good. So once again, we have a tautology here. So on the test, when I ask, is this a valid argument? You would say, indeed, this is a valid argument. I'm going to flip the page. We just did this one this morning. We just finished forming this argument right here. So I'm going to give you a couple more minutes to do this, and then we'll just talk about the last little topic for this section, and then we'll be done with section 3.5. All right, so I'm going to get started on this truth table. So here's my premises blocked together in some brackets. I'm going to start there, and then we'll talk about the argument. And again, this one's nice. The conclusion is just a simple statement. So that's a little bit less work. So I need this P or Q. Okay, we haven't reviewed this one this morning. When is the disjunction? When is the or statement true? Exactly, when either one of them is true. So true or true, the first row is true. True or false, the second row is true. False or true, the third row is true. And then two falses, that's the only false one. I need the squiggly P. That's the other premise. So P is true, true, false, false. So squiggly P is false, false, true, true. And now what I'm going to do is I'm going to combine them together with an and. As we just talked about, I'm going to label this right here that these are the premises, just so that we know what we're looking at. And it's an and statement. The and statement's true when both are true. So I've got true and false, that's false. True and false, that's false. True and true, and then false and true. So last but not least, then I'm going to take those premises. I'm going to link them together with Q. So Q is over here. So I'm going in this order right here. I'm drawing my arrow again because that helps me. So here's my implication. So here we go. I've got false, then true. Okay, that is true. False, then false. That's true. True, then true. And false, then false. So once again, I did not get super creative. I probably should have put an invalid one on there, but I just wanted you to see some valid arguments. So just know, if you're thinking, hey, Perkster, how would I know if it's invalid? If there's even one false in this last column, okay, then it will be an invalid argument. And it's really easy to have an invalid argument. It's a lot harder to have a valid one, although the evidence that you have so far would not appear that way. So here are some standard forms. These are some very simple arguments, and that if you want to remember them, you can. In fact, what we just had, that example 3 was this one, what's called the disjunctive syllogism, which is quite the mouthful to say. Okay, so that is a standard form, something that you would know would be a true argument. So what we're going to do with our last two problems is we're gonna use this table just to practice arguments in a different way. So I'm going to do example 4, then I'm going to have you do example 5. What we're going to do here is we are going to finish this argument. So the argument goes like this: I will attend the concert, or I will attend the volleyball game. The second premise is I will not attend the concert. So there's the given information. And I want to know, what is the conclusion that I would have to draw from that? What's the logical conclusion? Now, when you get good at this, you could probably do this without writing things down symbolically. I totally understand that. Okay, but this is our first problem. So we're going to go through and we're just going to make sure. So first step's going to be what we did before. We're going to write this argument, what we have so far symbolically, so I can compare with the given formats up there. So here we go. Statement P, statement Q. Statement P is going to be, I'm going to attend the concert. Statement Q is going to be, I will attend the volleyball game. So let's write that symbolically now. The first line is I will attend the concert, or I will attend the volleyball game. So that is P or Q. Okay, there's my word or. That's what tells me that. The second one is I will not attend the concert. So that is squiggly P. Then I've got the word therefore. Therefore, remember symbolically is those cool 3 dots right in a row. Okay, so now, according to the chart, looking up above, what is the conclusion that I can logically draw from that? Yeah, it's Q. It's the disjunctive syllogism again. In fact, this is another form of what we just did in example 3. So I'm just going to write this in a different color, just because I feel like doing that. So from the table, the conclusion I have to draw is Q. Okay, so this is from right here. And so now my last thing is going to be, okay, well then that means therefore, what? Therefore, Q is I will attend the volleyball game. All right, last problem from section 3.5, right below that, example 5, if you would, same thing. I've given you two premises and then left the conclusion blank for you to fill in.
Should we like remember this is what it says? All right, so I've defined my simple statement P, my simple statement Q. I've let simple statement P be you close the deal just from this right here. I let Q be you will get commission. Again, if you define them in the reverse, that's fine. It's not going to affect anything. Okay, you'll end up in the same place I end up. So then let's write this symbolically. This is an if-then statement. So it's a conditional statement. So if you close the deal, the P goes on the left, you will get the commission. The Q goes on the right. You did not get the commission, so that is squiggly Q. Therefore, so therefore are the three dots right there. And now I'm just going to go back up to the top. So I've got if P then Q and then squiggly Q. Which one of these is that in my chart? Law, that's a fun word to say, isn't it? It's the law of contraposition. It's this one right here. And so then that means the conclusion is supposed to be what? Squiggly P. Okay, so the squiggly P that I just wrote in pink is the conclusion. That is from the chart. And so now I will answer the question. How do we complete this argument? Well, we complete this argument, therefore, you did not close the deal. And there it is.